this is how a Bitcoin transaction life cycle is. So this is typically like, Rob opens his Bitcoin wallet, scans copies actually probably like recipient addresses using QR code, fill the amount and the fee to make the transaction happen, and sends it. Okay. What happens? The wallet signs the transaction using the Rob's private key. Okay. So digital signature, what you're talking about? The transaction is propagated and validated by the network nodes. Miners include the transaction in the next block to be mined. Mining time, okay, basically is the computational process of calculating the certain hash address. Okay. And certainly new Bitcoins are created. The miner who solves the proof of work propagates the new block to the network. And the nodes verify the result and propagate the block. Laura sees the first confirmation, and certainly there are new confirmations appear with each new block that is created on the ledger. So Bitcoin ecosystem, okay. So Bitcoin hardware manufacturers, mining platforms, okay. We have actually like a research and support, basically foundations for profits, venture capitals, security, okay, which is ongoing. And then actually we have payment processors, escrow services actually which are available. We have retail actually merchant directories of stores that accept actually Bitcoins. Then actually we have seen actually buying, selling and storing of Bitcoins. Financial services actually who helps in actually investing in Bitcoins and probably tell you actually like when to come out of the market, when to get into the market and all. So these are actually some of the ecosystem which is built actually around the Bitcoin protocol today, which has been supported actually takes care of various services. Okay, structure of a Bitcoin transaction. This is something probably interesting. So a transaction contains a number of fields. Okay, so you will have actually the version, okay, of a transaction. Basically, they specify the rules this transaction follows. Okay, it will have actually multiple inputs which can be there actually for a transaction. How many inputs are included could be it can be defined actually in 1 to 9 bytes. Variable actually one or more transaction outputs. And then you have output counter actually, how many outputs are included actually in this transaction. Variables actually outputs actually one or more transaction outputs, and 4 bytes actually is a lock time actually a Unix time stamp actually or a block number. Okay. So I mean, what happens actually in the when I say multiple inputs or multiple outputs, typically we will have actually let's say you mined a coin, mined a block actually on a blockchain network. Okay. You have, let's say you have mined actually $12.5 actually after mining. Okay, when we started actually the Bitcoin platform, actually we had actually $50 which was rewarded actually as part of the every block which was mined. And these rates are getting changed actually based on the number of blocks which are left actually in the network to be mined. Okay, so there's something called actually unspent transaction output. Okay, so we call it actually UTXO, okay, or unspent transactions output in a fundamental building block of a Bitcoin. An unspent transaction output that can be spent as an input in a new transaction. Okay, so let's say once you mined, we'll just see an example. I think we'll better understand that. So network keep track of all the available unspent transactions numbering in the millions. Okay, the first block contained, let's say, this is an example. The first block contained 50 mined BTCs in address A. Okay. The second block contained 50 mined BTCs in address A. A transaction sending 20 BTCs to address B and putting the change in the address C. Hope you understand what I'm trying to say. So this is first block, okay, which is the mined block of 50 BTCs. The second block contains actually of this 50 BTCs which was mined in the first block. A transaction is spending off 20 BTCs to address B and putting the change in the address C. Okay. The third block contained the 50 mined BTCs in address A. Okay. And a transaction spending sending actually 20 BTCs from B to D. Okay. So this, there are 3 blocks and this is what actually it carries. Okay. So on transaction output, okay, so all after 3 blocks, there are at least 4 unspent transactions. A has 2 unspent transactions worth 50 BTCs. If you remember actually why, the second block contained 50 BTCs, which is in the address A transaction sending of 20 BTCs to address B and 30 putting it back to address C. Okay, so this is nothing but 50 BTCs, okay, which has been spent. I mean unspent transactions. Outputs just 50 BTCs each. C has a single unspent output worth of 30 BTCs. Why 30 BTCs? Because this is actually what C has received from A. What it has been mined actually from the block A. Okay, and D has a single unspent output worth of 20 BTCs. So we know actually D has received actually 20 BTCs actually from B to D. Okay, so B received actually from A and then B moved it actually to address D. Okay, to the to party D. So these unspent transactions, and there are 2 spent outputs. 50 BTC generated in the first block, that's a spent output, spent in the second block. Okay, because it has been moved to B and C. And the 20 BTC created in the second block, spent in the third block. So which was generated actually when you moved actually 20 BTCs. This was a new transaction which you created from the unspent transaction to move it to address B. And this address B has moved from 20 unspent transactions from B to D has been moved into third block. Okay. So basically note that unspent outputs don't merge together. The 2 unspent 50 BTCs outputs at address A are separate and will remain separate at least until they are spent in a transaction. So basically, when you mine a block, okay, you'll have actually certain BTCs you'll receive, which is a spent transaction, okay, and you'll have actually you might actually do few more. You can do using that transaction actually, which has been spent. You may do at least next set of transactions, which will become actually unspent transactions to other parties because they're not spent those transactions. And it will have actually all those transactions, all unspent and spent transactions will have actually separate entries in your wallet. If you want to spend an unspent transaction, you need to probably create a transaction of unspent transactions to make them spent, or probably to spend that transaction. So Bitcoin transaction inputs and outputs. Firstly, 4 axiomatic actually truths about transactions. Okay, any Bitcoin amount that we send is always sent to an address. Any Bitcoin amount we receive is logged to the receiving address, okay, which is associated with our wallet. Okay, anytime we spend Bitcoin, the amount we spend will always come from funds previously received and currently present in our wallet. Addresses receive Bitcoin, but they do not send Bitcoin. Bitcoin is sent from a wallet. Now we go to Bitcoin scripting language. All Bitcoin transactions have scripts coded with its into its inputs and output mechanism. Okay, so basically we talked about actually inputs and outputs. If you look at it here, so basically yeah, this is actually how a typical Bitcoin transaction structure would look like. Sorry, you have actually the version number actually specify the rules actually this transaction follows. Okay, so these rules are nothing but the typically certain conditions which are met actually for the transaction to happen. Okay, then actually basically your input counter, how many inputs are included. Okay, variable actually the outputs actually one or more transaction outputs. So actually if you look at our example actually over here, this is actually nothing but actually one of the input to block B. Okay, which is actually again you have actually multiple outputs. So one is 20 BTCs, 30 BTCs have the multiple outputs, and then actually this is again an input transaction actually 50 BTCs which is mined, which is unspent transaction but is mined. Okay, so this is one input which is mined, and then you have 2 outputs. Okay, so this is what we are trying to say. You have variable likely output, one or more transaction outputs, output counter, how many outputs are included, variable likely output, one or more transaction outputs, 4 bytes, the lock time actually a Unix timestamp or block number. Okay, so what I'm trying to say here is, I'll just go scripting language. Okay, so we are saying actually all Bitcoin transactions have scripts coded into its inputs and output mechanism. Design goals: Fourth, like programming languages, old stack based actually simple programming languages, reverse polish notation, actually data is pushed onto the stack and the operation is performed. And composed of opcodes, actually the operations in Bitcoin is composed of opcodes. I'll just take one example and probably I think we'll explain this. So here actually if you really see, this is nothing but a simple example of a scripting. Okay, the script shown alongside will execute the values in the stack and will return to true if the equation is valid. If you see the execution pointer points to the leftmost actually starts with from the left. Okay, execution starts from the left. Constant value 2 is pushed to the top of the stack. Okay, execution pointer moves to next left and probably move towards right with each step. Actually constant value 3 is pushed on top of the stack. And similarly it it validates like what is the operator, and the operator add pops up actually in two items, actually to two top items out of the stack, which is 2 and 3 of the stack, adds them together. So which is nothing but the 5. Actually the operator add pushes the result 5 to the top of the stack. Okay, and constant value 5 is pushed to the top of the stack as we discussed. And then equals, it validates, operator equal pops the two items out of the stack and compares the the values, actually 5 and 5. If they're equal pushes, the equal pushes the true equals to 1 to the top of the stack. Okay, so this is basically nothing but actually, we are just showing actually how the transaction workflow happens actually, or validation happens actually, for the spent and unspent transactions actually into the Bitcoin world. Now, these are actually the most common types of Bitcoin scripts. Pay to public actually key hash, pay to public key, pay to multi-sign key, pay to script hash. Okay, so basically pay to public key hash, one of the most commonly used actually transaction output script, is used to pay to a Bitcoin address. Okay, so pay to public key hash is typically like what we see actually, typically used actually on a Bitcoin network, or and the addresses starts actually with typically with 1. Okay, and pay to multi-sign is another one actually which is used actually for forming a transaction. Okay, on the Bitcoin world, or and probably typically the address of the probably when you do the address of the multi-sign actually would be starting with a 3. Okay, so I'm like, if you see here, probably for Bitcoin addresses, you'll see probably 1 or 3 actually, starting with 1 or 3. I'm like, when you open up the Bitcoin addresses, you'll see that actually. Okay, so these are the typically two ones actually which are used most frequently. Okay, this is actually another one, pay to public key. This is a simplified form of pay to public key. This is not commonly used in new transactions anymore because are not very secure, are more secure. Okay, and pay to script hash, the scripts that contain the hash of another script called redeem script. See, you don't have to really understand the scripting and all. Actually, that's just for FII. With the more, the concept is actually more about the how the transactions are formed and how probably we have actually wallets actually which shows actually spent and unspent outputs against for all the in your wallet, for all the transactions which are being happening actually in your wallet. So if you have to see what are your unspent output, you have to go to the unspent wallet, under the unspent output actually of your wallets, or and probably for spent, what is the amount spent, you have to go to the spent part of your wallet. Okay, that's where the transactions will be listed. Okay, so and then actually how this transaction happens is using the scripting language. That is what we just talked about. Okay, and then actually these are the ways of doing the transactions actually, most common scripting types actually which are used actually to make the transaction happens. Pay to public key hash or pay to multi-sign. So pay to multi-sign, as I said, actually the address starts with 3. Here the addresses would start with 1. In case you want to send the probably money or exchange the money actually, one recipient to other recipient. By looking at the addresses, you can make out actually, what is the address, which is, based on the starting of the address, you can make out what is the kind of hash which is used. Is it a public key hash or is it a multi-sign hash? Okay, so nodes in Bitcoin network. Let's see actually what are the various nodes in Bitcoin network. So we have actually 2 nodes typically. Pruned selfish nodes. These are nodes actually which are a prune node is a node actually that prunes actually raw block and undo data by deleting it from disk. This can be achieved to save disk space. A selfish Bitcoin node is a node that does not upload new blocks or transactions to other Bitcoin peers in the network. Archival selfish nodes. Uh, an archival node is a full node that stores a complete copy of the Bitcoin data on disk. With this data, the archival node actually operator can make queries against the blockchain to find information pertaining to particular transactions or addresses. So pruned nodes actually, selfish nodes actually are typically if you really look at it actually, I'm like, if you have actually this lightweight wallets or nodes, okay, or probably the web wallets, okay, these are nothing but actually, pruned selfish full nodes, okay. Basically, you don't maintain the history of all your transactions onto the node, okay. You will just maintain actually the history of probably your own set of transactions if required, and you'll maintain actually nothing but actually, but you still have a view of all the, I mean, you still have a view of, probably if in case you want to know actually what are the transactions happening on the network, you can get that view of all the transactions which is happening on the network as well.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.